Hello everyone, I hope everybody is fine and okay, and I hope you have had some time to review your old material that we have learned so far in statistics. In this lecture, we want to discuss box and whisker plot as well as interquartile range, which is just one of the four measures of spread of data. So Peter is just like a teenager, works part-time selling cell phones. He works in a company or something. He sells cell phones. And number of cell phones sold in 1 year is given by the chart below. In the month of January, he could sell 51 cell phones. Maybe it was the beginning of the year. Everybody was getting cell phones. In the month of February, the business was slow. He sold only 17 cell phones. In March, it was March break, maybe holidays. More people bought cell phones, 25. He could sell. April, uh, he sold 39 cell phones. In the month of May, perhaps he didn't go to work that much. He sold only 7. But then in June, which was summertime, he could sell 69 cell phones. In July, 49, in June. July, 62. August, 41 cell phones. September, October, 26. And November, 43 cell phones. And in December, he sold 13 cell phones. So that's what his sales was. And every month, at the end of the month, he would record down number of cell phones that he sold. So this data obviously is unsorted data. So what we're going to do, first of all, before anything else, we are going to sort the data. So this next column in red is the same data, but it is sorted from the least to the greatest. So the least value is 16. It's 6. And the greatest value is 62. Okay? The least and the greatest. And right away, we can actually calculate the range of the data. There's a whole bunch of questions here. Question number 3, it says, what is the range of the data? So the range of the data is not that difficult to find. We can say range equals the greatest value minus the least value. So that's 62. Take away 6. That's going to be 56. So the answer is 56. So that's the range of the data, which shows the difference between the least data value and the greatest data value. Okay, so, but then it talks about median. It says, what does the median indicate here? So first of all, let's calculate the median. We have 12 values, so if you consider the upper half and lower half, so you have 6 data values in the top, 6 data values in the bottom, add up to 12. So we're going to have 1, 2, 3, 4, 5, 6 at the top. So this is 6 at the top, 1, 2, 3, 4, 5, 6 at the bottom. So I'm cutting the data set into 2 parts, upper half, lower part. Now, if I had 13 data values, the middle one in the sorted data would be the median, obviously. But right now, we have only even number of data values. So what I should do, I have to take the middle 2 values, and I have to find the average of those two, as we have discussed extensively in the past lectures, and I'm sure you have reviewed them. Otherwise, you wouldn't be watching this lecture. So I'm going to say the median, which is also known as the second quartile, Q2, is 25 plus 39 divided by 2. So use your calculator. Add them up, divided by 2, you get 32. So the median of this data set is 32, and it's also known as second quartile, and it's denoted by Q sub 2. And the median indicates that half of Peter's monthly sales were more than 32 cell phones, and half were fewer than 32 cell phones. Okay, that's the meaning of the median. So what does median indicate? We mentioned that. It indicates that half of his monthly sales were more than 32 cell phones, and half of it less than 32, or fewer than 32 cell phones. Then it says define interquartile range, okay? And the quartiles. Okay, so what are these? I know we have talked about it in the past, but first of all, a quartile is a value, okay? And in fact, we have three of them, okay? I'll let you know. We have first quartile, second quartile, third quartile. But what kind of value? These values divide a set of data into 4 intervals with equal number of data. So 3 values that divide a set of data into 4 intervals with equal numbers of data is what we call it a quartile. So I have to divide the set of data I have into 4 parts, as I said. So I have 6 at the top, so that means that I'm going to go 3 at the top, and then 3 at the top, and then 3 at the bottom, and 3 at the bottom. So 1, 2, 3, 4. So I divided my data set into 4 intervals with equal numbers of data. I have 3 in the top, 3 in the second part, 3 in the third part, and 3 data values in the fourth part. So they're all equal. So that's what a quartile is to begin with. And then interquartile, or well, actually I have to finish this up. I didn't mention what these values are. So I'm going to find the median of the upper half. So the median of the upper half is what is between 13 and 17. So if I add them up, divided by 2, that will be 10, 20, 30 divided by 2 is going to be 15. This is the first quartile we were talking about. Okay, so 15 is the median of the upper half, basically. And the third quartile is the median of the lower half, basically. So 43 plus 49 divided by 2. We need the calculator to punch this in, and it's going to be 46, I guess. And this is Q sub 3, or known as third quartile. So first quartile is 15, second quartile, known as median, is 32, and the third quartile is 46. And what is a quartile? I just gave you the definition earlier. A quartile is a value. Actually, we have 3 values for the 3 quartiles. What kind of value? A value that divides a set of data into 4 intervals with equal numbers of data. First quartile, second quartile, third quartile. So that's what it is. Now, interquartile range is the range of the central half of a set of data when data are arranged from least to the greatest. And it's also a measure of how closely data clusters around its mean. So basically, if I find the distance between Q1 and Q3, that would be interquartile range. So I'm going to say interquartile range equals 46 minus 15, which is 31. Okay, so when it says calculate the interquartile range, the answer is 31. That's the answer. In quartiles, we said what kind of values they are: Q1, Q2, Q3. And interquartile range, IQR, that is 46 minus 15. That's the range of the middle half. Okay, so we answered all the questions, I believe, except drawing a box and whisker plot, which is not that difficult. So basically, we have to show all these numbers in some sort of graph. But what is a box and whisker plot? It's a graph, end of the day. It's a graph representing the first quartile we talked about. It represents the median. It represents the third quartile, Q sub 3, of a set of data with a box. Okay. The least and the greatest data are represented by lines, we call them whiskers, extending from that so-called box. Okay, so box and whiskers. So now we have to see how we can draw the graph. The least value was 6, the greatest was 62. So 6 is somewhere here. I would say this is 6. So I go up. This is the least value. So least value, I start from here. The greatest value was 62, which is somewhere here. So I go, this is the greatest value. Okay, so I plus those dots. And 62 is somewhere here. All right. And then the first quartile is at 15. So 15 is right in the middle here. That's 15. So that's 15 here. And the third quartile is 46. 46 is here. So that's 46. And then we have 32, the median is right there. That's the median, 32. Okay, so I plot all these points. And now I'm supposed to draw a box starting with Q1. So this point here was Q1, the first quartile, and this one was the third quartile, and this one is the median, which is the same as the second quartile. Okay, now it's time for me to draw the box. So the box is drawn from Q1, okay, Q1 up to Q3. So we draw a box just like that. Okay, and the median is here. It's at 32, by the way. So this is the box, and now I have to draw the whiskers. Whiskers are straight lines on the left and the right, the line segment. So this is box and whisker plot, okay? So Q1 is clear, Q3 is clear, Q2 is clear, that's the median. Okay, so this is the median. We have the least value, which was 6, the greatest value. So this whole graph is known as box and whisker plot, which shows, how the data clusters around its mean. Interquartile range is a measure of how closely data clusters around its mean, obviously. So this box and whisker plot is just a visual demonstration of interquartile range and first quartile and third quartile, median and the least value and the greatest value. You see the whole picture basically using this box and whisker plot. Okay, by doing a couple of exercises, you'll become fluent in this, I am sure. Thank you very much for your attention and keep practicing.